Hello, everyone. This is Ranqiu from UIUC. Today, I'm going to present our measurement study on latency critical services running in serverless fast platforms. This work is in collaboration with IBM Research. In traditional cloud computing paradigms, application owners develop and deploy their applications in the cloud and choose the resources by themselves. On the other hand, serverless computing is a new paradigm in which application owners register their code base to the fast platform, and the cloud provider dynamically allocates and charges the user for only the compute resources needed to execute the functions. Due to its benefit, it's becoming popular for the deployment of bursty services such as online navigation, social networks, and other web services. However, function as a service suffers from high variability in internal latency, which hinders its adoption for those latency-critical cloud services with performance-based service level objectives or SLOs. Unlike traditional paradigm where customers can configure resources to overprovision, function as a service providers tend to collocate multiple containers on the same server to achieve higher utilization efficiency. In order to address this problem and answer the question whether function as a service is a good fit for latency critical services, the trade-offs between customers' latency goals and the cloud providers' utilization goals must be studied. In particular, we are interested in the resource granularity configuration in the workload consolidation policy. In our experiments, we tune the memory limits for each function container because CPU and other resources are allocated proportionally to memory limits in most function as a service platforms. Resource granularities are great points in a spectrum where a fine-grained policy allocates a smaller memory limits for containers, while a coarse-grained policy allocates a larger limit. A coarse-grained policy is used in traditional platform as a service or infrastructure as a service paradigms, where customers pay for the uptime of the allocated resources. In this study, we consider the memory limits above 256 MB as coarse-grained and the limits below 128 as fine-grained. To help understand what role a workload consolidation policy plays in the internal latency variation problem, our study focused on the following questions. And due to time limit, we will cover part of the first question in this talk, and please refer to our paper for more details. First, what is the trade-off among power consumption, CPU utilization, and internal latency in the decision-making of cloud providers for choosing a workload consolidation policy? We found that increasing resource granularity can reduce tail latency by 2 times, but will consume 1.75 times more power and reduce the utilization efficiency. The other 2 questions are about the shared resource contention problem caused by fine-grained workload consolidation and the latency breakdown variation in different workload consolidation policies. So to start with, in cloud service hosting, customers with latency critical services prefer lower costs and lower internal latency or less SLO violations. The provider values lower operation costs and better resource utilization. This figure illustrates the performance and cost comparison between the 2 policies under different workload scenarios for which we vary the arrival rate and the concurrency. For each scenario, we measure the 99th percentile internal latency and the average CPU utilization across all worker nodes. From the cloud provider's point of view, the fine-grained policy helps keep the server utilization at a higher level. Therefore, cloud providers prefer to stay on the right-hand side with a low operation cost and high revenue. The coarse-grained policy consumes much more power because the scaling out action at high concurrency levels, but it leads to less resource contention and lower tail latency. Therefore, customers would prefer a coarse-grained policy to achieve low internal latency, which is the bottom side of the figure. We also measure the average total power consumption of all nodes used to estimate the operation cost. The figure shows that a fine-grained policy helps keep the power consumption at a low level when the concurrency is high, mostly due to its packing more fine-grained containers for limited number of machines. To conclude, a fine-grained policy leads to lower operation costs and a better server utilization efficiency, while a coarse-grained policy offers the customers lower internal latency. Current function as a service pricing models incentivize providers to go over server capacity by setting more function invocations per unit time, while also increasing the execution time, which conflicts with the customer's latency objectives. An interface between the 2 parties to allow customers to negotiate function performance SLOs and the resource demands is missing. Inclusion of such performance SLOs helps resolve the dilemma but negotiation could be challenging due to various sources of SLO violations. Thank you for listening. Please check out our paper for more details.